Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this session we are going to find out the domain of this function f of x is equal to cosine inverse, and here we have natural log of x minus 2, right? So here we'll try to find out the domain of this function where we have the inverse trigonometric function, that is cosine inverse, and here we have the logarithmic function. So let us take natural log of x minus 2 as theta. So here we'll make this assumption, that is theta is equal to natural log of x minus 2. So now we can write this function f of x is equal to cos inverse theta, right? Okay, now from inverse trigonometric functions we know that the range of cosine inverse theta is given by this interval, that is 0 to pi, provided this theta belongs to the interval that is minus 1 to 1. So the principal value branch of cos inverse theta belongs to this interval, that is 0 to pi. This is the closed interval, and provided theta belongs to minus 1 to 1. So we can also write this expression as theta greater than or equal to minus 1, and here we have 1. So now we can replace this theta by natural log of x minus 2. So here we have minus 1, then we have natural log of x minus 2, and here we have 1. So now we have this inequality, right? And we have to solve this inequality for x, right? Okay, so now here what we will do, we'll take all these three numbers to the power of e, where e is the exponential number. So in order to solve this inequality for x, we have to raise these three numbers to the power of e. And remember, the function that is log x to the base a is always an increasing function for all values of x in its domain when we have a greater than 1. And here we have the natural log, and it implies that we have the base of the logarithm as e, and e is greater than 1, right? So we can raise these three numbers to the power of e without disturbing the direction of the inequalities. So we can now write e raised to minus 1, and here we have e raised to natural log of x minus 2, and here we have e raised to 1. So the purpose of raising these three numbers to the power of e is that this expression, that is e raised to natural log of x minus 2, is equal to x minus 2, because we know this result, that is m raised to log of p to the base m is always equal to p if m is greater than 0 and m is not equal to 1. And here we have e, because the base of this log is e, so the value of m is e, which is obviously greater than 0 and it is not equal to 1, and the value of p is x minus 2. So e raised to natural log of x minus 2 is equal to x minus 2. So here we have e raised to minus 1, and here we have simply x minus 2, and here we have e. So now let us add 2 throughout this inequality. So we have e raised to minus 1 plus 2, and here we have x minus 2 plus 2, here we have e plus 2. So this is e raised to minus 1 plus 2, and here we have x, and here we have e plus 2. So now this inequality suggests that x is greater than or equal to e raised to minus 1 plus 2, but less than or equal to e plus 2, right? So now let us see this log term here. Here we have a log of x minus 2, right? So natural log of x minus 2 is defined for all values of x for which x minus 2 should be greater than 0, because here we cannot have a negative number, because the log of negative numbers is not defined on the set of real numbers. So we must have x minus 2 should be greater than 0, that is x should be greater than 2. So we have to now merge this inequality with this one, that is we have to identify the common region between this inequality and this inequality, right? So here natural log of x minus 2 is defined when x minus 2 is greater than 0, that is x is greater than 2. So now let us take the help of the real number line. So now here we have the real number line minus infinity and plus infinity, right? And here the first condition is that x should be greater than 2. So here for simplicity, let us represent the numbers like this, that is 0, 1, 2, 3, 4 and 5, right? And here x is greater than 2, and here it is important to note that x is not equal to 2, right? So log of x minus 2 is not defined for x equal to 2. So we have to first discard x is equal to 2. So x greater than 2 implies that we have the interval that is 2 to infinity. So here we have this reason for this interval, that is 2 to infinity, and here x is equal to 2 is not included. Now let us represent this inequality on this real number line. So here we have x greater than or equal to e raised to minus 1 plus 2. So here we can write 1 over e plus 2, and here we have x, and here we have e plus 2. Now we know that the approximate value of e is equal to 2.718, right? And the value of 1 over e, 1 over e can be written approximately as 0.3678. So we can divide 1 by e, and we can get the approximate value as 0.3678. So here 1 over e is 0.3678, and here we have 2, and then we have x, and here we have 2.718, and here we have 2, right? So adding these two numbers, we have 2.3678, and here we have x, and here we have 4.718. So our x, it lies between these two numbers, including the endpoints, right? So 2.3678, it lies somewhere here, right, between 2 and 3. And this number 4.718, it lies somewhere here. So we have this reason, that is this inequality can be represented like this, including both these points, right? So 1 over e plus 2 is approximately equal to 2.3678, and e plus 2 is approximately equal to 4.718. So the representation of this inequality on the real number line is given by this line. So now we have to identify the common region between these two regions, that is first from 2 to infinity where 2 is not included, and from 1 over e plus 2 to e plus 2. So this number is 1 over e plus 2, and this number is e plus 2, and from these two regions we can easily conclude that this portion, that is this interval x belonging to 1 over e plus 2 to e plus 2 is the region which is common to these two inequalities, right? So the domain of this function is given by this region. So this interval which is closed from both the ends gives us the domain of f of x, and the domain is given by this interval 1 over e plus 2 to e plus 2.